Thanks for coming to our website of Smart Calculations. I want to show you, this is the screenshot of the Machinist Journeyman app, our second version after the Machinist APPrentice application. The Journeyman is loaded with many more calculations and references. We're going to cruise in here to the milling area, and you'll see that the milling area is laid out with inch per minute and inch per revolution, and then some miscellaneous calculations down here along with RPM and surface feet by themselves. Let's just go into a calculation here where you have surface feet and feed per tooth, and it's going to give you the RPM inches per minute. So let's pick a 3/4 inch diameter cutter. So we'd come in here and hit 0.75, of course, and it's a 3-flute end mill, and we're going to run 400 surface feet on this particular coating with carbide in the steel that we've selected. And we're going to come in here at a 5,000 feet per tooth. We're going to calculate. Now remember, here's the RPM inches per minute, just that fast. Remember this 30.6 inches per minute, because we're going to take this into a chip thinning factor now. Same cutter, 3/4 inch diameter, 3 flutes, surface feet of 400 surface feet, feed per tooth 5,000. But as this shows down here, we're going to have something less than half the diameter in engagement. This engagement width of cut, radial width of cut, is going to produce a thinner chip, which would rub the cutter. We need to increase the chip load to get it back to the linear 5,000 chip load to get this thickness of 5,000 at that angle of engagement. So let's say the width of cut is 100 thousandths on that 3/4 inch. So what's going to happen here is our regular 30.6, you're going to increase the chip load to a place where you're going to be going almost 45 inches a minute now. Your tool's going to run faster, it's going to run longer because you're actually feeding it instead of rubbing it. Okay, there's another calculation for ball nose. That's going to give us, due to the depth of cut, not the width of cut now, but to the depth of cut, will give you a true cutting diameter, which is then going to base your surface feet off of that diameter and take your chip load, and it's going to give you an astounding RPM inches per minute here. So let's take that 3/4 inch end mill again. We know it's a ball nose though, and we'll say it's 3 flute because we know where we were calculating at 400 surface feet and 5,000 chip load on a regular end mill. It was coming out at like 30.6 inches a minute. But now let's take and say we're doing a 30 thousandths depth of cut, the depth of cut here on a 3/4 inch, and let's see what happens. Now your true cutter diameter is not 3/4. In fact, it's less than 300 thousandths at 294. So if you take the surface feet and calculate the 294 diameter, here's your RPM, and now look at the feed rate. Instead of 30 inches, we're at 78 inches a minute. Okay? At any given time, we can release this so we can see the diagram below, and we'll go back to the main menu. There's another one of these for 45-degree face mill cutters, because it also has a 30% higher feed rate due to the chip thinning factor. Okay? Now, along with that, you can back calculate from diameter. We'll say 3/4 inch, and we're running 3 flute, and the RPM was, we'll say 3,200, and we were running 45 inches a minute, and we're going to back calculate our surface feet and chip load. Okay, so there's a nice back calculation. This is a nice one here for thread mills. Now, due to the size, I had to reduce the font sizes, but as we begin to put in thread milling programs, let's say we're going to do half 13 thread. I'm just filling in the 7 fields that we had to put in here. So half 13, 400 surface feet, 3 flute. We're going to come in here for a cutter diameter of 300 thousandths and a thread depth of 400 thousandths, and feed per tooth we'll say is 1,000ths per tooth, and hit calculate and release the keyboard, and there's line by line your G-code program right there. I know it's small, I'll work on rotating this so it's larger. So that's most of the milling section right there, and we'll have more for turning and others. Thank you.